Endeavour will be leaving Kelly Air Force Base in San Antonio tomorrow morning.
I'd like to introduce Dr. Charles L. Beach, who will explain the fine details of the experiments he's conducting.
I won't explain any fine details, KT, but this is a pretty interesting experiment. Basically, it's an X-ray imager. It's called the URA, Uniformly Redundant Array, and it uses a coated aperture to collect X-rays. We've been looking today. We finally got a way to get data collected. The data goes on to the ESS tape recorders that we've been having problems with. So with the IFM that we did earlier today, we're going to be able to collect actual science data for URA. We're all really happy about that. The instrument itself, if you want to take a quick look out in the bay, maybe we can do that. Let me see if I can get the camera up. The URA is hard-mounted to the ESS pallet. It points out along our right wing. So we maneuver the orbiter in order to point the instrument at an X-ray source. Now, earlier today when we started out, we did one data pass looking at the galactic center, which is about 30,000 light years away from us. So the light coming from there has been traveling through space for 30,000 years. Later today, we're going to, after that, we think we took a look at an X-ray source. Okay, we're getting the payload bay picture up now. You can see the business end of the URA right to the left of the IBSS doer, and you can just make out the URA emblem on the instrument. The aperture is to the left as you look at the picture, and you can see that it looks out basically aligned with the right wing. The count rates, we're basically counting X-ray photons with the instrument. It's kind of an interesting device. The front end of it is a coated aperture with some 25,000 holes drilled in sheets of stainless steel with a stack of, I think, 16 sheets. The aperture, the holes in the aperture are arranged in accordance with the Fibonacci series. Ed Fenimore, the PI, says that the Fibonacci series have magical properties. And that's the extent of my understanding of the mathematics involved in reducing data. In any event, the X-ray photons, which are coming in at a rate of only a few a second, pass down the barrel of the instrument, go through a mylar window and into a chamber of xenon gas, where the X-rays strike molecules of xenon. And Kathy, you can explain the quantum physics that goes on here to anybody that wants to know. But they're changed into UV photons, which then pass through a calcium fluoride window, a monolithic crystal of calcium fluoride, which is transparent to ultraviolet radiation. Now, once the ultraviolet photons get into the next chamber of gas, which is filled with P20, with a trace of another gas called TAMI, something else, according to our PI, which has magical properties. Those ultraviolet photons are turned into a shower of X-rays when they strike molecules of gas in that chamber. That shower of X-rays then passes through an electronic grid, and the location of each electron is then mapped, and that data is stored in the computer, stored on the data tape. That's the data that's being transmitted to the ground. Now, by using Fourier transforms after the flight, in effect, Dr. Fenimore and Dr. Dupree will reverse the process, and they will track back that shower of ultraviolet photons and compute the position of the original X-ray photon as it came through the into the aperture of the instrument, and thereby construct an image of the object. This instrument's unique, I understand, I'm told, in that it does both imaging and also does energy as you know, packets are always, food is always distracting, Kathy, I apologize. In any event, the instrument is an imager, and it's also can also measure the energy spectra of the X-ray source. I think later on today we're going to be looking at well, quite a few different X-ray sources. One is known as 4UO. Have you heard enough X-ray physics for now?
We don't know what he's talking about, Kathy, but we're trying to help him out all we can here.
Trouble is, neither do I. If you really want to understand this, you'll need to go to talk to Ed Fenimore and Diane Dupree.
Well, seriously, this is probably the most quietest time we've had in the flight right now, this last hour anyway. And we would like to take the opportunity to thank everybody that's worked so hard getting this flight ready to go and pulling off the flight once we got up here. I know with the problems we've had, it's been a challenge, I think, for all the experiments. Everybody's had something to think about and work on during the flight, and they've just really come through. And all the months and years of preparations that have gone into this flight have really paid off. I think Rick had a good comment a while ago. We just finished up the IBSS experiment that we've been doing for the last 6 days, and in the checklist, I think he said we found maybe one mistake, one trivial error in the whole checklist, and the checklist is about that thick. So that really says a lot for all the thousands of man hours that went into making the experiments work and the checklist work and pulling all this off. So well done, and a kudo to everybody that has worked so hard.
We'll pass that on, Mike.
Mike, tell me how to explain a little bit about the IBSS since we just wrapped it up. It's hard for me to know where to start since I've been working that program for about, seems like forever, but maybe about 3 years. And of course, there's a lot of personal satisfaction for me and that I've been working on it for a long time, and that with the help of the whole team, we've pulled it off and we put it away, and we're going to bring it home, and hopefully there'll be 30 some odd hours of deployed ops on the tape and another 20 or whatever hours of operations on the end of the arm. And I guess the thing that I find most satisfying is that so many people took part in it, and there were so many people that played key roles. I remember when I have worked other jobs, I always took it upon myself to make sure that I treated my part of the task as being the single most important thing that had to get done, because that guaranteed that I did my job right. And it's obvious that all the other folks that played a part in this mission felt that way too, because it was put together so well. And it was, in a way, even though we had a problem early on the deployed mission, it was satisfying in that we had considered that problem and we thought about it, and we had a plan for how to work around it, and sure enough, that's the way it worked. And it was really gratifying to see that come together. It's been a lot of fun. It's been a lot of work. For me, the hard part's over now. I get to kind of float around and look out the windows a little bit and help Lacey when he needs a gopher and make the meals. Make the meals. I thought I would just eat the meals. It's been fun, and it's been a real good experience, and I'm looking forward to talking about the IBSS mission from space with all the folks that have been putting so much time together, getting it ready.
Rick, there have been a lot of people down here working very hard trying to keep ahead of you guys, and we just want you to know that we're all coming to your party.
It's going to be a great party. You're going to get to meet a real brain surgeon there.
Kathy, the mission's not over yet. We've still got a couple days of hard work ahead of us here, and we're looking forward to doing that as best we can and coming back and debriefing everybody on everything that's gone on up here. So once again, thanks to everybody that's worked so hard to pull this one off.
Roger that.
This is Mission Control Houston. One of the Earth observation opportunities that the crew on board Discovery will be taking advantage of in the next few orbits will be pass over Taiwan on Rev number 109. This orbit will take Discovery over the economic miracle of Asia. The problems of deforestation and soil erosion and industrial pollution are increasingly felt in Taiwan, plus the complex geology of the island is also of significance to Earth observation scientists. On orbit 114, Discovery will pass over Mozambique in Southeast Africa. Mozambique's soil erosion problems have attracted much attention in the last decade. Overgrazing and tree cutting for fuel are the prime causes of the environmental degradation. Mozambique has experienced severe drought conditions over the past few years, which also has been induced widespread starvation. A little bit earlier on this orbital pass, Discovery passed over the Persian Gulf area, at which point Commander Mike Coates remarked on the oil fires going on in that area. Coates says that from the vantage point of 140 nautical miles on Earth, that the fires were, quote, just amazing.
This is Mission Control Houston. We're now receiving live television showing the blue team at work, Mission Specialist Guy Bluford and Don McMonigal and Greg Harbaugh at work on the flight deck of
Discovery. Guy, CIC, we'd like for you to skip step 3 of PFO2B. No QEM sequence for this block.
Okay, we'll skip 3 and I'll stand by for what you want me to do on ST-13.
Discovery, we're looking out the window with you at Australia now.
Very good. I hope you're enjoying it as much as we are.
Now, you're probably enjoying it a little bit more.
I think you're right.
And in this television from Discovery, its reaction control system jets, the small steering jets that keep it at the proper orientation while it's in orbit, can be seen firing. It's currently in an automatic system that the orientation is set into the computers, and then the jets fire automatically to keep Discovery pointed the proper way. Mission Control Houston, we're now continuing to receive live television from Discovery. This view showing a star field seen from one of the cameras operated remotely in Discovery's payload bay. And as we watch live television from Discovery's payload bay, the black and white cameras in the cargo bay, this is believed to be an aurora by Earth scientists here at the Johnson Space Center as Discovery continues across the extreme South Pacific. This is a view of the aurora, or as it's more commonly called, the Southern Lights. Discover currently with a wastewater dump underway on board. That's a dump that's done as normal housekeeping procedures on board the orbiter. Wastewater is ejected overboard from a vent on the orbiter, ejected overboard at very high pressure in order to move the instantly crystallized water away from the orbiter.
Discovery Houston, we're watching your water dump. It's a great show.
We agree, Marcia. We've seen some pretty spectacular water dumps when we get in a position where we have the moon to the west and the sun just coming up in the east, and we do a water dump. We get the shadow of the orbiter crossing the dump, and it looks like a shower of snow with the moon in the background.
You are putting that on the camcorder, aren't you?
We've got some good stills. We haven't put it in motion yet.
Camcorder takes a great shot of that.
Okay, we'll give it a try.
In this view from Discovery, cities in central Mexico can be seen. The lights from cities. Discovery currently on the night side of Earth. And these lights from Cuba. Discovery is approximately 2 minutes away from moving into sunrise. On this orbital path, Discovery will continue up the east coast of the United States. This brightly lit city on Cuba is Havana, Cuba, the capital of that country. And the Florida Keys brightly lit here as they lead up to the Florida Peninsula. And these lights are from Florida, with Tampa located on the west coast of the Florida Peninsula, and Miami. And the Kennedy Space Center located on the right here with this nighttime view of Florida from Discovery. Discovery passing over on a very clear night and seeing the light of Florida.
This is Mission Control Houston. The crew is preparing to do an 8-second primary reaction control system burn to support the Arizona Imager spectrograph.
We're going to float a few things for you here, Brian, during this burn so you can see the reaction.
Okay, Mike, we're looking forward to it.
Commander Mike Coates radioing down that he's going to float a few items in the cabin for this 8-second burn to give us an idea of what happens to items aboard the vehicle if they're not secured during a small burn of the reaction control system. About a minute and 20 seconds away from the burn now to support the AIS data take. Again, looking from the back of the flight deck forward out the commander's windows aboard Discovery. In the foreground is Commander Mike Coates, and seated in the commander's seat at this time is pilot Blaine Hammond. And the reaction control system burn in progress as evidenced by the movement of the articles in the cabin.
And Mike, I'd like to relay a message from Admiral Truly to you.
Go ahead.
Okay, Admiral Truly has asked us to pass along his congratulations on an outstanding mission, and added that since today marks the 30th anniversary of Alan Shepard's flight into space, we should remember that event and all the members of the NASA team that have worked so hard to make 30 years of manned spaceflight possible. Your flight is an extension of that great tradition.
Well, thank you, Brian. We appreciate that. Those are good words from Admiral Truly. Seems like a quick 30 years, doesn't it?
Sure does.
what you're seeing here is the orbiter prior to the fine pointing. Right at this point, Lacey was measuring the offsets from the orbiter to the desired position that we wanted the orbiter in for the gas release. So in a few seconds here, you'll see the orbiter move across the screen as the IBSS made a small attitude maneuver to orient to properly locate the orbiter. There's some orbiter thrusters firing. Okay, now this pause maneuver is underway.
Well, 30 years ago, we were flying one man at a time. Now we're flying 7 or more. So we're all wondering what it's going to be like 30 years from now. How many people will be up here and what kind of vehicle? Rick's saying he hopes it's a vehicle with a lot more track storage area than this one has. A happy anniversary from the STS-39 crew.
A lot of folks are will take that appreciation from you guys, and you know we're all down here really supporting you and proud that you're up there doing the great job that you're doing. So keep up the good work, and we're looking forward to getting you home tomorrow, and we'll pick up with another 30 years.
You bet. Well, we get the honor of being on TV, I suppose, but there's thousands of people out there working very hard to get us up here and get us home safely, and we sure do appreciate that.
Kathy, I'm wearing one of several medical DSOs that we're doing on this flight. This one's Mike and Blaine and I all participated in this DSO where we put this whole getup on 3 different days during the mission. We've also worn this outfit several times pre-flight, each time for 24 hours, so we get to try and sleep with this thing on. It's a blood pressure cuff that pumps up about every 20 minutes and takes your blood pressure. Meanwhile, it's taking an ECG more or less continuously. And we've got several different variations on these things, but what they're all about is trying to understand what the body does in adapting to space, and especially what the real concern is after you've been in space for a while, a week, 2 weeks, with the extended duration orbiter will be a couple weeks, and then with space station as much as months. The real concern is what adaptation changes does the body make that you then have to recover from when you come back to Earth after landing. There are a lot of funny things happen. For example, I'm now just a little bit over 6'4". I've grown a little bit over an inch, and in fact, the other day we measured just about everybody's grown an inch or more in the last week or so in space. That means when we come back down, you've got to lose that inch again as the Earth sort of smashes you down. And your blood pressure changes, your heart rate changes. There's just a long list of different things that change in space flight. And so the medical folks are trying to understand how all those changes work, and the ones that make it hard for you to adapt when you get back to Earth, well, they want to come up with countermeasures for. So this is just one of those, one of the many tests that we're doing along those lines. The next thing we're going to try and do is show you a little bit about meal preparation. So we're going to make a switch over here.
Okay, Kathy, a lot of children ask me when I'm out talking at schools, how do you prepare food in space? And how do you eat and so forth? I think the first thing to notice is that everything takes about twice as long up here to get accomplished, whether it's preparing food and eating a meal or washing yourself up or going to the bathroom or going to sleep or whatever. It just seems like everything takes twice as long because you have to move kind of slowly up here. The food we eat has taken a lot of steps forward since the early space flights. We don't have the food in a tube anymore for the most part. We have rehydrated food now. In fact, the whole process has taken a lot of steps forward since my first flight about 7 years ago. When I flew on the first flight of Discovery, as a matter of fact, we had a food warmer, just a metal suitcase to warm up the food as we prepared it. Now we have a galley, which is really terrific. It's a water dispenser that we can dial up exactly the amount of water we want, either hot or cold, and exactly how many ounces we want. We have an oven to warm up the food after that, and it really saves a lot of time. What we do is the food comes in several different packets. Some of it comes in pouches, just like this, and we'll stick it. Close up the oven. And it's a convection oven, so the air is being forced through there to make the food hot, and it works quite well. As I said, most of the food is dehydrated when you have to add water to make it work again. You'll notice that all the food packets and all the drink containers have little tabs of Velcro. If they didn't have those Velcro on there, there'd be no place to stick them, and they'd float off, as they frequently do anyway. So we use the tabs of Velcro to hold them in place. The food containers tell you exactly what it is. In this case, shrimp cocktail. It says add 3 ounces of cold water, let it set 5 to 10 minutes. So that's what I'm going to do, is add 3 ounces of cold water. Now here's another one. This is chicken consomme soup. It says add 6 ounces of hot water and let it set 3 to 5 minutes. That's what I'm going to do as well. Now once you take it out, it's not completely absorbed. You have to mush it up a little bit, make the water, the shrimp absorb the water. Okay, here goes 6 ounces of hot water. Now, most of the drinks that we have now come in these foil pouches. This is something new as well. In this case, it says tropical punch. It says add 8 ounces of cold water. Some of the fellows like to add a couple more ounces sometimes. Now, each of the food packets has little colored dots on them. Each crew member has his own color. Commander is red, and the pilot's yellow, and so forth. So you keep track of whose food is where. You know when somebody's eating yours. Now, what we usually do to prepare a meal is one person will volunteer or be asked to come down and set up the meal trays. What he'll do is get out everybody's tray and set it on the locker. Distribute the food on here and then rehydrate the food or put it in the oven as you need to. Of course, you can't drink right out of this without having a straw in the drink container. And the straws have little clips on the end to cut off the flow of liquid when you stop drinking. Otherwise, it just continues to squirt out. You have to clamp it off like that to make it stop in 0G. Really hits the spot. So once you get all the food rehydrated and heated up, you take it out and put it on everybody's tray. Now, one of the fascinating things about eating in zero gravity is how you keep all this stuff tied down to something. So these trays are kind of ingenious. We've got several different ways to hold the food down. The trays are sized just right, so you can stick in a container like that and it'll fit just right. So you've got rubber grommets to hold some of the cans of things like this is pears right here. We have Velcro on some of the all the food containers, and we have Velcro tabs on the trays as well. Of course, we have magnets to put the silverware on there, right here. Yeah, I keep my silverware in my in this pocket we carry in our pants. That way I can always find it when I get hungry. And we also have little clips like this to help hold the food on there. And then, of course, we have Velcro on the bottom of the food tray itself to help stick it to your pants. And you can actually eat while you're floating. You have to be very careful when you open something, though, because the food will tend to float out, especially things like rice and scrambled eggs. For some reason, they break into little pieces. All you can do is bump it a little bit, and they start floating everywhere. So we're always chasing scrambled eggs and rice around the orbiter. As you can see, preparing the food and then cleaning up afterwards takes an awful long time. And it's roughly twice as long as it takes down there. But I notice everybody's eating pretty well up here, so it must be worth the effort.
Mike, I bet you there's some school children who would like to see you make a peanut butter and jelly burrito if you have any tortillas left.
That's a good point, Kathy. One of the things we tried doing is carrying bread into orbit. Bread tends to get a little bit stale and crumbly after a few days up here. So what we do now is we carry tortillas. Yeah, Rick says the tortillas start out stale already, so we don't have to worry about that.
This is Mission Control
I'm not
Houston.
crazy about peanut butter, but Blaine loves it, so he knows exactly where it is.
Commander Mike Coates is currently in the process of going through the what it takes to eat on orbit.
Okay, I'm trying to get the peanut butter out, Kathy, as you can see. Now, one of the problems with these trays is they have to pack them pretty tight to save space. They have mesh over the trays. Try to hold the food in, but all food tends to float out. So here we have everything we need for a peanut butter and jelly sandwich. We got a tortilla, and peanut butter, and jelly in this little container. Now, the trick is you got to set the peanut butter down so it's got Velcro on it. And so does the lid to the jar. But the problem is the tortilla doesn't have any Velcro on it, so you can just let that float. Everybody's laughing at me, Kathy, because peanut butter is the only thing I can't stand.
Well, Blaine will eat it for you.
I'll give it to Blaine, yeah. Now, one of the things you have to learn when you get up here is how to hold yourself down, because you float away. You can't push on anything. If I tried to open this door or open one of these locker shelves without bracing myself on the floor or against something, I would just be pushing out against the air, and I wouldn't accomplish anything. I'd push myself away. So we've got foot restraints down on the floor, foot loops, if you will. We can slide our feet into these foot loops. Well, now I got to clean up the mess. I don't think you want to watch that.
Rick, we think it would be interesting if you could show us the tags machine and how you get your morning mail.
So what you're looking at, of course, is a tag machine just down by the ladder between the flight deck and the mid deck. And it's been working great on this flight. It's been the best thing we could have had happen to us as far as keeping up with the flight plan, because it would have been a real mess trying to transcribe all the changes we had by teleprinter. Anyway, unfortunately, when you call down to get the mail, I'd already pulled it out, and I'm not real keen on putting this back in there, but basically this little slot here is where it all comes out. It's just nothing more than a pretty much fancy fax machine like Yeah, back here on Earth, only it sends it up here, and we get the maps of our pages look like this. And of course, we've been pasting them in our flight plans, so our flight plans have grown quite considerably since we got up here. And we barely have rings big enough to hold it on now. As you can see, it's all been cut and pasted. Rick says to say we need to make the flight plans a little bit bigger next time so we'll have room to tape all these pages in when changes start happening. But we've been real fortunate to have the tags on this site and have it work so well. And we've been able to not only make copies of one flight plan, but all the flight plans we carry on board. And it's helped us keep up with what's going on. And it's a real tribute to all the folks down there who have been working hard at keeping up to date, keep ahead of us, because things happen pretty quick up here, and we need to know where we're going and what our next maneuvers are, and those kind of activities. So keeping ahead of us has been a real task and a real challenge, and they've met it quite capably.
Thanks, Blaine.
And with that, we'll switch back to the flight deck and let Lacey show you what he's up to. KT, I thought I'd take you on a quick tour of the AFP-675 talent, if we've got just a couple of minutes here. I'm going to downlink another camera to you. Taking a look at the 675 pallet here, and of course the instrument, the main instrument that we operated during the first 2 days was Cirrus, and of course you saw a lot of some of the low-light TV downlink of our auroral observations were pretty spectacular. Liquid helium cooled the infrared telescope, essentially, a spectrometer and a radiometer. It's done with its mission, and I think we're pretty happy with the data that we got from it.